I'm a strong believer that the future is one of highly automated vehicles, and our pathway there may be much longer than many would like to predict. Since the early days of autonomy, nearly 100 years ago, we have had a quest to move the driver out of the driver's seat into either a remote control situation, which we see and we talked about in Sertash's earlier talk, or out of the vehicle completely. So if you do a quick Google search, the first experiment with autonomy was really back nearly a century ago. 50, 60 years ago, GM invested a fortune in the topic for the time. The context of Autopilot, for instance, is elegantly shared in some YouTube clips that GM had as advertisements at the time. In the early 80s, several prototypes. The DARPA Urban Challenge, where we aimed from an academic industry partnership perspective to begin to develop robots that tried to navigate the early 2000s. In 2009, let's call it, the modern era of self-driving was launched by Google's quest to change how we live and move. And at the time, technology that was forecasted to impact us in 5 years or less. In the 10 years since that time, numbers upwards of $16 billion have been spent on highly automated vehicles and countless more on technologies to support that and evolve automation into consumer vehicles. So as we look to the next century or more, what's next? And I, for one, do not see the small-scale deployment of automation a considerable investment to be success. How do we transform how we live and move with the support of technology so that there is a business case to move society forward in convenient and productive ways? So one of the key problems here is when we begin to talk about autonomy, it means different things to different people. As I talked about in 2018 in my Forbes blog, when we think about what autonomy perspectives are, everybody has a different answer. For those focused on level 4 and level 5 automated systems, it's all about seamless mobility without a human involved. To many of us, aspects of hands-free driving. To others, policy in particular, intermodal connectivity. It's all about getting people to steel-on-steel rail or buses or other convenient mobility services and getting them off the roads. To me, how do we build a mobility solution that moves safety towards a targeted threshold that is much more strategic? Where beyond the current crisis, one of the society's biggest quests is how to deal with the global health crisis that's on our world's roads, where 1.4 million globally die a year. So how do we begin to think about bringing definition to the key problem in our quest? What are we trying to solve? Is it just packages? Is it people? Is it safe mobility for all? So one of the harder pieces is that when we look at consumers in particular, and we talk to individuals in some of our survey work, that we talk about levels of automation. We talk about the complexity of whether the human is involved as a teleoperator, whether they're involved to recover and drive through an intersection. One of the complexities is when you go to an average individual on the street, all we really understand is, am I driving or am I riding? And from a foundational terminology perspective, whether we're engineers or communicators in the media, we need to begin to focus on the fact that consumers who are expected to benefit from these technologies, by and large, don't know what we're talking about. That means consumers are expecting around the corner technologies that are going to automatically take them to the doctor's office, drive their kids to school, or do other things conveniently for them. And that may very well be the distant horizon. But riding, or a child riding in the back seat of an automated vehicle, is something that is several decades at best from changing how we get our kids to school. So moving that communication forward from these definitions and really beginning the education pipeline, because one of the myths about automation is that we need less human expertise. We need to actually educate people along the way on how this changes occur and set that reality gap and reduce that reality gap. So a number of years ago, now in its 5th year, I formed the Advanced Vehicle Technologies Consortium at MIT, which is now supported by about 17 different automotive stakeholders, from manufacturers such as Toyota and Jaguar Land Rover, Audi and Volvo, to safety suppliers such as Aptiv, V&E, or Lear, Google, as well as other key safety stakeholders, to begin to look at how people are using advanced driver assistance systems, early stage automation, automated driving features such as Autopilot, Super Cruise, Pilot Assist, and other related technologies in production vehicles on roads today. How do we look under the cover at how people are beginning to leverage technology to help inform and build better educated guesses as how to innovate for tomorrow? So a lot of the world in autonomy has looked to the far reaches of what may be possible 10, 20, or 30 years in the distance. I, for one, believe there's a lot that we can learn from looking at what's occurring today to iteratively move faster in changing the safety landscape on the road today and getting technology from the classroom, from the laboratory, into people's hands to improve mobility decisions. So how do people adapt to these technologies? How do they use them or avoid using them to begin to leverage technology more strategically as part of our lives? One of the things that we quickly realize that there is a huge data gap. There is much projected benefit of technology in cars, and the product forecasters do a great job of saying, how good can this system be? Unfortunately, in the complexities of real-world life, crash data and claims data from the insurance industry will tell you that these systems are far less effective on average than projections. ABS is a great illustration. We presume that ABS systems would reduce crashes. The insurance data proved a number of years later that that wasn't the case. Electronic stability control was the additive features that really showed the benefits of ABS braking systems. So as part of ADT, as we begin to look at these problems, there's a number of things that we begin to very quickly understand. That many of the developments of advanced driver assistance systems and automated driving systems are really built upon a set of conditional operating characteristics. Operational characteristics that engineers have designed for engineering systems. No mystery, we as engineers need specifications. Unfortunately, those specifications are not well understood by the consumer. So drivers don't necessarily have the skills required to leverage these technologies. How many of you on the webinar here today have purchased a newer vehicle and can't quite figure out how the anti-lock braking systems, lane keeping systems, forward collision alert systems are all there to support you, let alone the automated driving features. Many systems require driver management and oversight beyond the capabilities of human attention alone. Technologists building these systems often assume that we as humans will behave ideally. As Dan Ariely's book points best, we as humans are predictably irrational. Who would truly pick up a cell phone while they're driving down the road if they were truly concerned about getting from point A to point B safely? And finally, our infrastructure is far less than ideal. Potholes and high technology do not mix, let alone the weather complexities that we observe here in New England and other places of the globe. So it's not saying that past research in automated driving systems and advanced driver assistance systems is wrong. It's just limited in scope in comparison to how real people are beginning to touch these technologies as part of real life. So how do we iterate forward from here? So in the video here, we can see an individual driving in one of our equipped vehicles here with Autopilot, fidgeting with something in their lap, reacting to emergent changes in the roadway environment. Who would expect that an individual here is going to attend to the world around them when the driving responsibilities are no longer there? Perhaps it's the salient looming effects of what's going on around us, but what's going on our nation's roads and the changes in risks and the fatality numbers are really predictable based upon some of the technology changes that we see. GM Super Cruise, on the other hand, has a driver management system. We can watch the hands kind of melt away from the steering wheel during an individual's first use of the automated driving feature. Convenient, intuitive, comforting. And I think GM Super Cruise features really an important system, not because of the automation itself. The automation is good for a first generation system, but it's the innovative driver management system that is really critical. So when much of the technology world looks at the automation here, they say, hey, it's not really that good. Well, it isn't. It's not aiming to be a level 4 or level 5 automated system. It's aiming to be a system that includes the human as part of the decision loop, leveraging human expertise when it makes sense and machine intelligence combined together, fused together, much as the aviation industry has long proved since the early 80s was the key to cockpit safety. So a couple features of the GM system. We begin to move from level 0 or manual control to level 1 or assisted driving, ACC, automated cruise control, over to level 2 or lateral control and distance control together. It's the transition harmony between these states that allows people to learn effectively and begin to leverage these systems. We are not born with the skills to understand how to work with autonomy. We need to build them. And it is an intuitive design of these systems that it's key that we begin to learn about the pathways to these technologies. So if we look at a couple of the key features within the system, call it the blue state that GM has designed in here, an override state. I'm not comfortable with what the automation is doing. I want to pass a car. I want to change lanes, allowing the human supervisory control. The key here with Super Cruise is that there's a driver management system that only allows you to look away from the road for up to 6 seconds. We need drivers relatively attentive with the brittle automation that exists today. So again, the key, allowing us to supervise the automation simply and seamlessly, and the automation to resume control when it can. Let's call it the red state, where the automation has exceeded its operational bounds and it is looking for the driver to take control imminently. The alarm I'm not playing here, obviously cueing an individual's attention, changes in the illumination in the instrument cluster, something is wrong. So in the case here, in stop and go traffic, the automation looking for the human to support it. Well, much has been said about the fact that perhaps humans are terrible overseers of automated systems. They are. But can we use technology to support the human and include them to be better overseers? And the aviation community, as I mentioned earlier, has really done that since the early 80s. That has led to the advances in aviation safety. There's a reason that there are pilots still in many commercial aircraft. They're there when things go drastically wrong to try to help. Key is ensuring that they don't touch the technology when they shouldn't. So automation in and of itself, ACC in this case, distance control, increases monitoring costs. We look at things more. In essence, by some definitions, automation creating a distraction in the vehicle, distracting attention away from the roadway, looking at the instrument cluster for more information. So as we shift from traditional drivers to modern drivers with technology supporting us, our roles as drivers is changing. No mystery that the cab of a vehicle looks more like a cockpit with dials and knobs today than it did a few years ago. How do we begin to ensure that we can connect the human more seamlessly to this technology? So can a driver maintain sustained attention? Not really. It's much more of a two-way street. And in the lab and the team, thinking much more about how we develop and enhance two-way collaboration between the human and the automation. Mutual support, allowing the automation to understand, is the driver there as a backup? Allowing the driver to more informative understand how to build and where to build trust in the automation. It's all a two-way street. And in some sense, by many definitions, and Google talked about this in the early days of their self-driving car program, is developing this two-way street is as complex, if not more complex, than developing the automation features in and of themselves. The key is, though, is that we are transitioning from a human-driven model where our trust in technology and our comfort in the ethics of robot decision making hasn't been fully formed, to a future of automation as opposed to revolutionarily moving people out of the driving role. So when we look to the future, we need to be more focused on successfully developing collaboration between the robot and the human. Whether that collaboration is from a driver in the driver's seat or a teleoperator that's going to need to step in and ensure that those who are in the cab of the vehicle are comforting and trusting in the situation. So when we look to the future, much like the aviation industry has harped on, drivers have a role in the successful deployment of automation. Much of the L4, L5 community is focused very much and very core in the technology, which may very well make sense. But when we look to the future, we need to look to harmonizing the role of supervision. Where and when can we monitor, manage, and motivate drivers or operators so that we encourage safe operation and more convenient mobility? This isn't new. Automation-enabled vehicle systems have delivered on improved safety. As I mentioned earlier, electronic stability control. We believe strongly that automatic emergency braking will have significant impact on safety. Driver attention and related awareness may be at historic lows. Everybody who's not driving quite as much right now, roads are safer than they've been in decades. You know, when you are out there driving or walking, watching how inattentive folks are around us. Well, it's not just drivers, it's even folks walking across the sidewalk in Cambridge, focused on their smart technologies around them. So increased automation really needs to be coupled with increased comfort, mobility, and safety. It's really a little carrot and stick here. What do we want? We want comfort. We want increased mobility. We want safety. And some of the sticks we can use are motivating individuals to behave in a more compliant manner so that we can collaborate. So collaboration, monitoring, and readiness to take over in extreme conditions that move outside of the domain at which engineers can build systems is really critical today. It's no mystery that new interfaces are going to be needed. It's really a communication issue. How do we develop systems that monitor, manage, and motivate drivers here? It's all about using new research and new innovations in infotainment, communication, and context-related integration. Whether that's a heads-up display or a full windshield display is an open question of the future. And I think many of the traditional manufacturers and suppliers are investing in these areas, but perhaps they've been a little distracted in the $16 billion quest for pure self-driving, where we need stepping stones on our way to get there. So as part of this, we really need to, in one sense, be thinking more deeply around human-centered considerations of attention management. We've been focused for so long on trying to get the distraction out of the car, the smartphone, the cell phone conversation. Perhaps what we've been missing is those technologies are being brought into the car because driving in and of itself is boring most of the time. It's not attentive enough. We don't need to attend to the road all the time because nothing's happening out there. As we automate more, no mystery, less attention is required most of the time. But in the rare instances where something goes wrong, how do we ensure that we're redirecting attention most efficiently? The Yerkes-Dodson law of arousal suggests that perhaps we need to be calming and relaxing drivers when they're overloaded, overstressed, and over-distracted by secondary activities. But we need to be alerting them and promoting reasonable attention strategies when they're not. So perhaps this is a very complex mix of how do we solve distracted, drowsy technology influx, driving along the context together. And we believe strongly in the lab that we can do this with the aid of automation, supporting drivers effectively. So when we look to the advances in HMI that are going to be critical to supporting drivers and riders, is really new display contexts. How do we ensure that drivers are aware of the mode that the vehicle is operating in, that they are aware of what's occurring around them, and they are aware of the operational relevance to different information? When is it critical to be alert and ready to take over? When is it okay to relax a little more. One of our partners, Lear's Learning Intelligent Vehicle concept, is a core illustration of how you bring context-aware computing to production-level vehicle systems. More effective multimodal interfaces, how do we use haptics, auditory cues, visual displays more seamlessly together to ensure the elevated alerting? How do we develop more innovative external HMIs so that the pedestrians moving through a crowded intersection around drivers are alert and aware of the likely activities of a vehicle? Perhaps this is also an important aspect where we think about salient advertising space, because by and large, as we are driving less, the advertising potential of both the interior and exterior of the vehicle is going to change. Integrating this communication, infotainment, and safety systems through synergistic interfaces is really critical to the automated and connected mobility system we all seek. This isn't about building technology for technology's sake. This is building technologies so that we can find new pathways to enable safe mobility and resources and the development of products people want in their homes. Defining success here is going to be far more than getting a robot on the road delivering groceries. It's far more than a technological competence to build better LiDAR, radar, more cheaper, more effectively. Consumer perceptions, experience, the cost of buying this technology even in your own car or renting it and sharing it in an Uber. Federal, state, and local policies are probably going to be the governing factors here. How do we enable leadership so that the organizations working here see a pathway to success over decades? Our federal government here in the United States has not been providing strong leadership. We need to be thinking about how do we ensure that folks are driving in a straight road. I'm not sure I'm concerned about which lane of the interstate they're on, but they're all moving in the same direction. That when something happens that goes wrong, we have the policies and procedures that we don't repeat the Uber accident of several years ago. How do we begin to look at the infrastructure requirements? We talked about 5G earlier. How do we ensure that the roads are paved effectively so that robots can effectively navigate? How safe do these systems truly need to be? The ethics of autonomy is a complex Pandora's box. For me, I believe that if we can move safety effectively from where we are today, iteratively forward, we're making good progress. Could we set a standard looking for a 5% reduction in global fatalities in a set year, 10% after, 15 beyond? In some sense, technology agnostic. Doesn't matter how we get there. The key is that we are moving toward a safer mobility ecosystem. So how these pieces come together is really going to define the success of our mobility system and how autonomy can impact how we live and move. It's no mystery that the current economic climate is going to slow investment here. How do we encourage the strategic targeted investments so that we see success in autonomy in a business context over the coming decades? I, for one, believe the policy pieces are critical. It's all about paving the roads effectively so that we can see less risk in investment. Today, in the US in particular, there's a fractured relationship between the public and private sectors in mobility. How do we get the public sector and the private sector working more seamlessly together? The private sector needs an understanding of what the frameworks for success are going to be. The expertise in technology, in insight and understanding is not, however, in the public sector. The private sector needs to talk about a little more of what do we need the roads paved like? How do we need to paint the road lines? I, for one, believe we need to take a much more overseeing public health perspective on the risk benefit of safety. I talked about this in a TEDx talk nearly 2 years ago. This is a health crisis. We need to look at innovations that move that risk benefit curve forward in productive ways and endorse them. And we need to limit those that increase risk. That means we do need to test on public roads, but we need to test much more strategically than many states allow today. We need to look beyond engineering standards, where SAE builds a standard and everybody races towards that standard, to continual process improvement. As we look at low-level and high-level autonomy as it exists today, we don't know what the goalposts look like. We need to look at doing better week by week, month by month, year by year. The industry that is driving autonomy, the research community, needs to look at the safety cultures that exist in aviation. Accidents that have occurred in the last few years, whether those are with Tesla's Autopilot system or higher levels of automation, transition issues, and some of the reporting requirements in California or beyond, are not acceptable in the safety culture that is needed. We need to look to building a trusted system. Only if consumers trust the technologies, whether that is as a rider or as a driver, will we see these technologies moving towards achieving their potential in the coming years. Policy leadership, as I mentioned earlier, to enable technology development. We're seeing a consolidation here among OEMs. MIT spin-off Autonomy, purchased by Aptiv, now in a joint venture with Hyundai, announced earlier this month. Strategic alignment in industry sectors with higher risk and billion-dollar investment is critical. But how do we motivate the public sector investments that are required? Paving roads effectively and building the connectivity infrastructure is federal trillion-dollar investments. Obviously, something that needs to be very well coordinated. So as we look forward here, I, for one, believe the future very well may be autonomous. In some sense, artificial general intelligence is the future. Some would believe it's just around the corner. I believe it's several decades, if not the best part of a century away. Significant changes in how we live and move will take decades, and increased collaborative industry innovation. It's not a revolution of robots on our road. It's an evolution of robots. So we will continue to see higher level automated vehicles emerge in different technology improvements. But the key is evolving the business cases so decade-long investments can continue. Managing consumer expectations will be critical. When consumers are looking for technology that's impractical, they're not going to be happy with the practical. That means that they will not be moving to buy new vehicles quite as quickly and looking and unsatisfied with what they can ride in. Policy and industry collaboration is critical. Only if we have a vision forward that is synergistic can we maintain the billions of dollars of investment. It's all about connecting humans here. It is not about building a robotics logistics enterprise that humans are not involved in. We're about delivering packages and people to end users. Trust is critical. If I don't trust what's moving on around me, I'm not going to walk across the busy infrastructure. I'm not going to get in the vehicle. I'm not going to purchase it. I believe that for the foreseeable future, several decades, collaborative driving developments in the level 2 standard level, SAE levels, are going to be critical. As a savior to the automotive industry in revolutionizing how we move in vehicles that we own today. It's not that I see the traditional auto industry's model of consumer-owned vehicles as the distant future. It's just the practical realities. And we can innovate around those realities to build business cases for autonomy into vehicles today that assist the Uber driver, but don't aim to necessarily replace the Uber driver. And with that, I'm about nearly over my 30-minute quota.